How to divide hexadecimal numbers. In this tutorial, we will describe how to divide hexadecimal numbers. In the terms involved in math operations video, we discussed terms involved in division. Since we will be dividing hexadecimal numbers, the operands involved in division are dividend and divisor. The result will be the quotient and possible remainder. For example, let us divide the following. Okay, so as we mentioned with division, the terms involved are dividend, divisor, and quotient. For this example, we're going to use the value 625,725. For the divisor, we're going to use the value 243. And our expected quotient should be 2,575. Towards the right, you'll see I put it in a form just how you usually see it in grade school. And we can have the value 243 is going to divide into 620,105. And at the we'll display the quotient. In this case, it would be 2,575. Towards the right, we have his hexadecimal representation. So the value 243 is represented in hexadecimal as F3. The value 625,705 is represented in hexadecimal as 9,8C3D. Before we begin the computation, let's look towards the left. We have some notes. Right at the top, because you see that we're dividing F3 into the dividend 98C3D, we want to go ahead and represent that in decimal by the value 243. The reverse of division is multiplication. So what we're going to show is certain multiples of the value 243. So you'll see the first column all represent decimal values. So when we multiply 1 times 243, we get the value 243. When we multiply 243 times 2, we get the value 486. 243 times 3, we get the value 729. As you look towards the right, like for 243, its hexadecimal representation is F3. And for the value 729, its hexadecimal representation is 2D9. At the bottom, you'll see we have the hexadecimal letter representation. For the value A, we have 10. B represents 11. C represents 12. D represents 13. E equals 14. And the value F represents 15. So let's compute. All right, towards the right here, we're going to divide hexadecimal value F3 into our dividend 98C3D. So let's start. So let's look at, you always start with the first digit in the dividend. It's a partial dividend at this point. So does F3 goes into 9. And the answer there would be 0. And so F3 times 0 is 0. And then we subtract 0 from 9. And so that leaves us with a 9. And then we carry down the 8. And that completes the cycle. So the next cycle is, does F3 goes into 98? The answer is 0. And again, F3 times 0 is 0. And so we subtract 0 from 98, and we get 98. And we carry down to C. So now the next cycle, we ask the question, does F3 divides into 98C? And this is where we have to look towards the chart to the left, and that's what I wanted to show. So we have 10 is represented by the letter A. So what it's saying is F3 times 10, or A, will produce a value 97E. And so F3 goes into 98C 10 times, but we have to represent it in hexadecimal by the letter A. So A goes here. And we have over here in the slide here to the left that F3 times 10 is a hexadecimal value 97E. So we put that here. And so we subtract. Okay, so we have C minus E, just how you do it with regular subtraction. So C minus E is the same as saying 12. Let's put this out here. So we have 12 minus E, but E is represented as 14. So what that tells us, we don't want a negative number. So what I would do here is cross out the 8, and a 7 goes there. And so when we borrow, we're really adding 16 into and 12 together to subtract 14. And when you add 16 and 12, you get 28 minus 14 is the new subtraction. And when we subtract 28 subtract 14, we get the value 14. But we said in hexadecimal that is represented by the value E. So E goes here. And so really we have 97 minus 97 is really 0, but we don't need to put that there. So we'll bring down the 3. And then 3 goes here. Does F3 goes into E3. It's not on our chart over to the left, so it's a value of 0. So 0 goes here. And then to complete this cycle, let me see, 0 times F3 is 0. And then we subtract that, and that leaves us with E3. And then we complete the cycle and bring down the D. All right, so to begin the next cycle, we ask the question, does F3 goes into E3D? And as we look towards the chart, our note left, we show that E3D is represented over here to the left. And it says that 243 times 15 equals a value 3,645, and its hexadecimal representation is E3D. So that says that it goes up, F3 goes into the value 15 times, but we got to represent the value with the letter F. So F3 times F is E3D. And then we subtract, and that leaves a value of 0. And so that ends the computation. So let's erase and let's show that the quotient is indeed the value 2,575. All right, so we have A 0, F, and F is in position 0, 0 is in position 1, and A is in position 2. So when we compute this, we have A times 16 to the second power plus 0 times 16 to the first power and plus F times 16 to the 0th power. And so this is the same as saying 10 times 16 to the second power is 256. And when we have 0 times anything, it's 0. So 0 goes there. And this computation, F is represented as 15. And anything to the 0th power is 1. So 10 times 256 is 2,560. Then we have the value 0. And then we have the value 15. And that does come out to be the value 2,505. And this is what we wanted to show. Next, let us perform another hexadecimal division. This time we will divide numbers with a decimal point. Okay, we're back once again. So for the dividend, we have the value 11,027.25. Our divisor is 14.5. And our quotient is 760.50. So we showed it towards our right, and we showed it like we would normally see it in grade school. So it's 14.5. Goes into the value 11,027.25, and our expected quotient would be 760.50. Towards his right, we have 14.5 is represented in hexadecimal by the value E.8. The value 11,027.25 is represented in hexadecimal by the value 2B13.4. So to make this computation easier, we want to first notice that we have two digits in this computation that are beyond or to the right of the decimal point. Here we have the number 8 is to the right of the decimal point in the divisor, and also the dividend has one digit. In this case is 4 to the right of the decimal point. So we need to consider two places when we perform this computation. So what we do is we want to just pretend like they're not there, and what we do is just pretty much move it here. So we have a full E8 that's going to be divided into, let's see here, so this is 2 times here. So 40 goes there. Okay. So we'll pretend like that it doesn't even exist, and what we'll do here is just go ahead and say E8. Well, actually, let's erase this. Okay. And we'll consider its computation coming back. Okay. All right, so we have to consider two decimal places when we actually perform the computation. So we ask the question, does E8 goes into 2? And the answer is 0 times. So 0 goes here. And 0 times E8 is 0. and we subtract 0 from 2, that leaves 2. And then the first cycle will be complete once we bring down the b. So our next computation, we want to say, does the value E8 goes into 2b? And the answer is 0. Zero times E8 is 0. And we subtract 0 from 2b, and that leaves 2b. And then we bring down the 1. So now we ask the question, does E8 go into 2b1? And the answer is yes, it goes in 2 times. We look towards the notes towards the left, and that's 2 times. And 2 times E8 is 1d. And we subtract 1d 0 from 2b1. So in this case, we have 1 minus 0 is 1. So 1 goes there. And we can't have b subtract d. It's going to produce a negative number. So what we're going to do is, in this case, we know we're going to borrow. So we change that 2 to a 1. And when we borrowed, we added 16 to 11 because b represents 11. And that produces the value 27 minus d, but d is represented as 13. And when we subtract, it gives us the value 14. But we said that in hexadecimal, the value 14 is represented by the letter E. So we put E here. And then, of course, 1 minus 1 is 0, but we do not need to represent that. And to complete the cycle, we bring down the value 3. Actually, this goes here. Okay, so 3. So next cycle, we ask, does E8 goes into E13? And the answer is it does. It goes in 15 times. So we look here towards the left, we have the value, we said for E8, this value is 232. And we multiply that 15 times, we get the decimal value 3,480. And its representation is D98. So we say that goes in 15 times, but that's represented as F. And F times E8 is D98. And then we subtract. So we have 3 subtract 8. Again, that's going to produce a negative number. So I'm going to borrow. We're going to convert this 1 to a 0. And so that gives us 16 that's going to be added to 3, which will produce the value 19. And then we subtract 8 from 19. This will give us a value, just to double check, would be 11. And 11 is represented by the value b, so b goes here. And once again, we want to go to the next significant column. We have 0 at the top, attempting to subtract 9, and that's going to produce a negative number. So we also going to borrow again. So we take 1 from E, and that leaves D. And when we borrow, we have 16 goes, or added to 0, will produce 16 minus 9 and that will give me a value of 7. So 7 goes here. And because we have now D on top of D, and so that's saying D subtract D, that's going to be the value 0. And since it's 0, we don't need to indicate it there. And then to complete the cycle, we bring down the value 4. And so this gives us 7b4. So that completes the cycle, and we go to and ask the next question: does E8 goes into the value 7b4? And the answer is yes, it does. It goes in 8 times, because 8 times E8, as we show to the left, is a hexadecimal value 740. So 740 goes here. And then we subtract. And so 4, or subtract 0 from 4, we get 4. When we subtract 4 from B, that's the same thing as saying 11 minus 4 is going to give us a value 7. And then 7 minus 7 is 0. And since 0 represents nothing, we're not going to display it. We'll go ahead and bring down our last value, which is 0. And that completes the cycle. Now we have to ask the question one more time. Does the value E8 goes into the value 740? If we look towards the left, we see it goes in 8 times. So another 8 goes up here. And so we got 8 times E8 equals 740. And so what we're going to do is subtract 740 from 740. And that's going to produce the value 0. And that gives us a stopping point right there. So we have to consider, as we mentioned from the beginning, that we had 2 digits to the right of the decimal point. We have to find a way to get that back to produce our computation. One thing we did notice was that there was 1 digit in the divisor that had 1 decimal digit towards the right of the decimal point. And so we're going to put that back. And so what we're going to do is that decimal point goes back here. So that's represent 1 there. And then there was also 1 in the dividend. So we also put that back, and that goes here. And so that's represented up here in the quotient. So what we want to show is, does the value 2F8.8 represents the quotient in decimal, the value 760.50. So what we'll do is just move this out here. So 2F8.8. And so we have 8 here is in the 0th position, F is in the first position, 2 is in the second position, and because 8 is to the right of the decimal point, it's in the -1 position. And what we want to show is we have 2 times 16 to the second power plus F times 16 to the first power plus 8 times 16 to the 0 power and plus 8 times 16 to the -1 power. And so this is represented as 2 times 256 plus f can be represented in decimal as 15. And this is times 16. And then we have 8. Anything to the 0 power, we have 16 to the 0 power. That's represented as 1. And we have 8 times 16 to the minus 1 power. That's represented by the value 0.0625. Okay, so let's multiply this out. I got 256 times 2, that's 512. And then we got 15 times 16. That represented as 240. Then 8 times 1 is 8. And then when we multiply the value 8 times 0.0625, it's 0.50. And its final result would be 5112 plus 240 plus 8 and then plus 0.5. And it does indeed come out to be 760.50. And this is what we wanted to show. This puts us in a position for my next tutorial where we describe the addition of octal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.